Hello. Ah, that's better. Welcome, everybody. See a lot of us here, so you obviously people are still enjoying lunch, but thank you for joining us. My short talk will be about component level performance testing. Really, why you should performance test in part of dev as part of the DevOps message. A little bit about me, Ian Molyneaux. I've written a book on performance testing. Because I didn't think there was quite a gap in the market. There wasn't really much written material available, so I got my courage together and for the first time wrote a book, and it was really hard. But it's there, and it's been out for a couple of years. Currently, by what I do for a job, I'm associate director of a company called Spike 95, and they're a UK-based performance and technical testing consultancy. So we do a lot about performance. And I also work with a number of performance and APM tool vendors in an advisory capacity. So I'm usually pretty busy. Okay, performance testing. Who here does performance testing? Who here does it all the time? Okay. Who feels that they do it well? Okay. Well, you probably do. You probably think of performance testing and you think of the end-to-end model. So users talking to a software application. And of course, today we have the internet, and a lot of businesses are very e-commerce focused. So the performance of the end user is obviously very key. So we tend to do our performance testing from here. Drive in, simulate this end user piece, drive in load, response times, infrastructure data, how much load is on our web servers, how much load is on our application servers, how much load is on our data. That's all good stuff, and I'm not saying we stop doing that by any means. That's very, very, very key. Because a lot of businesses now, particularly e-commerce, they're looking for a competitive advantage. You can save a couple of seconds on your typical web page response time. That's worth money. So that's the driving factor, I think, in a lot of businesses these days. So they're looking for this competitive advantage, this psychological analysis of how we as humans react to fast, medium, or slow applications. So this 3 to 6 seconds seems to be the place to get. Down here, it'd be good to get here, but it's pretty hard. And sometimes you have to do an awful lot of work just to get a very small increase in performance. And you have to say sometimes, is the time worth it? This is where performance testing and DevOps can give us a little bit of assistance. Because businesses, of course, are very much driven by peak events these days. You've probably heard Black Friday, Cyber Monday, Halloween, Christmas, the sale events. There's big spikes through the year. So businesses are very much looking to make sure that they're ready for these big days, because a lot of businesses make a lot of their money on these days. I don't know if it's the same in Russia, online business. It's just the amount of money taken on Black Friday in the UK is just stupid. But it's very, very important. Companies obviously want to be ready, make sure their websites don't collapse when these big events happen. Of course, that never happens, does it? So if we go back to our performance testing view again, this time a little bit more of a technical diagram. I think those of you that do performance testing, I'm sure you understand that performance testing helps identify a lot of problems or potential problems in your application and the infrastructure. So obviously the end user piece, what's our end user response time like? Do we have any problems with the network, with the configuration of our load balancers or our web servers? And in the system under test, do we have enough capacity? Because that's usually where we get things fail. Looking how good is our code quality, the application server tier, if that's part of our deployment model. What's happening on the database? Have we got contention? Have we got problems with how we've factored our SQL statements, our stored procedures, all of that. So an end-to-end performance test, if you like a traditional performance test, gives us a lot of good information and continues to do so. However, if we move it to the I suppose, move our performance testing focus a little bit, if you like, into dev, we're sort of homing in on very specific things. So at this stage, we probably don't have our full application. Early days and on what's being developed. So we're very much in looking at code quality and making sure that that we're following the design. At this point, we can bring in performance testing to help us get an additional feel for how well we're developing our code. Is there anything fundamentally wrong? And I think that's the value that bringing performance testing into dev actually gives. And it's very much part of the DevOps message as well, because it's sort of shared knowledge. It's improving the whole, the team has visibility of how well or not so well the code development is going from a quality and also a performance perspective. Because when you performance test in dev, the environments you're going to have, they're not going to be production-like. They're going to be the development environment. But you can still add a little. Whoops, lost people. Yeah, we're back. So you can start to get a little bit of understanding about is this code well written? Is it going to scale, or is it just going to fail as soon as you apply a little bit of load to it? So you start to tease out those sort of metrics. And it helps us identify and correct bad design decisions as well. So if things are this wrong, at this stage we can address them, correct them, and it doesn't cost as much. It's not as cost to the business. It's an old message really. Shift left, test early, test often, but why not performance test as well? Because you have the opportunity. Because by getting this early insight, any design failings can be picked up, and design failings can lead to performance defects, can lead to an ability to scale, which is a lot of what particularly e-commerce businesses are concerned about these days. So why not find out about it early at this stage? I forgot to start my clock, so I'll need you. And of course, by doing this, we also optimize the speed and quality of delivery, because that's another key deliverable part of the DevOps message, making sure that your businesses these days, they've moved from monthly releases to weekly releases to daily releases, and for your Facebook, your hourly releases, or Google, maybe your half-hourly releases. So the quality and speed of what you're developing and delivering is so important if you're going to try and meet these sort of very, very aggressive timescales. And again, with e-commerce, the businesses have to be really agile. A competitor does something, they need to follow suit. They don't want to wait 6 months to bring in a new feature. They want to bring it in as soon as they can. So DevOps again, but also by leveraging performance testing at an early stage, it gives you some additional values. Is my change going to scale? Is it going to work? And we do that by performance testing in dev at the component level. Anybody got any ideas for what I mean by a component? Any thoughts? Oh, okay.
API?
Yeah. Or something that uses an API or consumes an API, if you like. Also, I think of them in 3 terms. Micro, so the smallest software entity that can be executed in its own right. Could be a unit of code, a couple of lines of JavaScript. It might use an API, might not. But as long as you have something you can run, you can potentially performance test it. Then you can have macro components. Something like you may be developing a little piece of code that does something, but it might have to make an API call to an enterprise service bus. So you could think of the enterprise service bus still as a component, a big component, but still a component. So the micro component, if you like, is calling the macro component. And then, of course, we've had a talk today about containers. So you could think of a container as a component as well. Again, it's a self-contained entity, but it can also be tested as an entity, and you could also test it early from a performance perspective in dev. Why not? So that's what that's my thinking around a definition of component. So as it relates to developing software. Do you agree? Is that a fair statement? Okay. So, when we're performance testing, what metrics should we be capturing? Well, when you do end-to-end performance testing, obviously you're capturing response times, you're capturing throughput values, seeing if there's any errors occurring, you're capturing metrics off the servers you're loading up, the database. Sort of metrics we capture at this very early stage. I think we start with execution times. Recall we have our component as maybe a unit of code, maybe it's something we can execute. It'd be good to understand across builds how long that execution is taking. Maybe build 1, it takes 20 milliseconds. But by build 10, it might be taking 300 milliseconds. So obviously there's been a regression in the development cycle. If you're not testing for this, could easily slip through. It might still be working, might still work fine, no problem. But by the time this piece of code is promoted up and becomes part of the full application, you've taken that big regression in dev and you've moved it into production potentially, and that could have serious consequences. So just simply how long something takes to run is an important metric to capture at this very early stage. That's it. There's a sample. And it might do something. It might process a file of orders, and maybe the business has put an SLA on that this component has to process a file of orders within 30 seconds if there's 1,000 orders in the file. So you can actually start to do this sort of testing potentially at this very early stage as well. So there's some value there. The other piece, obviously, response times. So API again. So if our component calls an API to our enterprise service bus, we want to understand how long that takes. And again, across builds, does that regress? Hopefully it won't. Does it stay the same, or maybe it improves? So from build 1 to build 20, before this piece of code gets promoted, we understand that our API calls have remained consistent, maybe have improved a bit, and maybe they also meet a business SLA that's been set. Maybe when you make a request for, I don't know, some data that assists you doing a search, that turnaround time can't be more than 10 milliseconds. So you can measure that. So that's other value that you're picking up at a very early stage. So you're starting to build up a performance profile pretty much of your component. And I think that's useful information to have. And then the other piece, of course, is the resource footprint. So you're still probably loading up a server. Your component will be using some CPU, be using some memory. It'll be doing a bit of I/O. So why not measure that as well? Because from build 1 to build 20, if our component still works, but goes from using 10% of CPU to 100% of CPU, that's something I'd want to know, because obviously there's been a change. And that's important because between builds, if any of these metrics suddenly change, then someone's done something. So you can go in immediately and correct it if it needs correcting. So again, you're finding that out very early on. That's value. And that's all part of DevOps as well. Starting to get this visibility and understanding at a very low level of what does this piece of code I'm developing do? I need to know more than it's just a piece of code that I write, then I give it to somebody else. So it raises the understanding, I suppose. This bit of code has to do something, and it has to be performant, and it has to be well written. And of course, once we have captured these metrics, we want to do something with them. And as we talked about, we can compare immediately. Maybe there's a business SLA that applies to this component. These are probably less common at this stage, early stage in the development life cycle, but they could still be there, and we have something to compare. If it's not there, we at least can create our own benchmark at build 1 and then follow that as more builds are deployed and tested. So we get this trending, if you like. We start to see trends across builds for those metrics we've just talked about in terms of what we've actually captured. Okay, let's do a little case study. I'm actually working with a business in the UK at the moment, large e-commerce fashion business. They've just added Russia to their international market, so there's a Russian website. You might be able to guess who they are. They sell clothes and for between 18 and 30-year-olds. And however, they are also in the middle of migrating from, they're replatforming. They're moving to a microservice API-based architecture, largely hosted in Microsoft Azure. Anybody here work with Azure? Oh, okay. So worker and web roles and all that good stuff. They're very much wanting to get to the point of creating reusable services that can be consumed by other parts of the business. So in a simplified view, we have a Scrum team here. They're building effectively a service called Delivery Services that has two service endpoints, and the checkout and bag of their business of their application will consume these two endpoints, among many others. So this gives us an opportunity at this early stage in dev to test. When the Scrum team start their work, there's probably not going to be much around to test for a while. There might be some of this which the endpoints won't be there, but it might be executable, so you could start to do some timings maybe. And the consumer out here, well, in order for these guys who are developing this piece, or maybe it's already ready to do some testing, these guys have kindly created some stubs. So at least this consumer here can call stubbed endpoints. And you can start to get a little bit of these metrics we talked about captured, even at this really early stage. So here, more infrastructure stuff. How long does it take to run, and then what is the CPU, memory, I/O footprint? These guys might be in a position to do that, depends how much they've got written, or maybe it's still just on paper. And as things move on, when the endpoints become live, then we can start to continue our testing. We can now actually get some real metrics from our consumer here. How long are these calls taking? Do they meet the SLA? What's my resource footprint here? What's my resource footprint here? When this guy calls this endpoint, what does it do to this component here? So you can start to test all these interactions if you like. You would anyway, but there's no reason why you can't start capturing performance-related metrics around this, just so add to the sort of the functional metrics you like that or functional testing that you would be doing. Does that make sense? Okay. And then eventually it's all finished, ready for promotion to the next level of testing. Maybe typically it's a system integrated testing. That's normally the next stage you move to. And we have these benchmarks. We've created a performance benchmark so that when everything's ready, the final build, we're happy with the resource utilization, the timings, and we're confident we've written good code. This is quality code. It's been well tested from a functional and non-functional perspective, and we're quite happy for it to go up to the next level of testing and to sit. So I think this is happening. We're in the process of implementing this. This is a little bit of a cultural change. It's developers, they love change, love having to do extra things as part of their normal day-to-day work. So we're working in a collaborative way. It's look how good this is. It helps what you do. But seriously, developers, Scrum team, they have enough to do already. This is something extra. So to be worth doing, it has to deliver demonstrable value. And I'm confident it does, and certainly the company I'm working for is starting to see that. There's a couple of comments around this. I mean, to make things easier, we can reuse stuff. If you're using automation for functional testing, why not use it to at least do some of your performance-related testing? That really is just collecting more metrics. So you might have some automation around maybe calling a service endpoint, and you're testing to make sure it works. So why not capture response time? Why not capture other metrics as well? In a lot of cases, it's simply adding some more counters, or maybe if you're a Windows shop, collecting performance monitor counters for CPU memory. It's not a big deal, and it can be automated and just included as part of your normal test configuration. And why not bring monitoring tools into your dev test environments? You find a lot of businesses, and this was the case for the company I'm working with currently, they'd invested in a lot of monitoring tools for production, but none of that was being used in dev or test. So why not bring those tools in to help, if it makes sense to do so? So they can be used to capture these additional performance metrics. So why not? And of course, in economies of scale, also environments. We talked about you're unlikely to have a production test environment at this stage, but that's no problem because dev and development you don't tend to. It really should just be size. As long as you can do your testing, that's really all you need at this stage. As long as you can do your automation testing, or maybe manual testing sometimes, but you don't need to create a special environment to do performance testing in dev. I think that's the key message out of this. There's not normally any requirements. So you're just adding to what you've got or reusing what you've got already. You still have to obviously control your build deploy configuration. That doesn't change. It's just some extra testing, some extra metrics that are being collected, and if you can bring additional monitoring, like anybody here use APM tools like New Relic or Dynatrace or you could use those at this level to get a very detailed view of the performance of your code, what you're developing. No reason why not. So, and test scenarios, pretty simple at this stage, unlike performance testing where they can be very complex. Don't need to at this stage. All you're doing is just, most cases, just repeating your functional test automation with capturing a little bit of extra data. And then maybe if you need to do a little bit of concurrency, you can do that with functional automation too, being a little bit creative. So there's not necessarily a need to invest in new tools. You can leverage what you've got, but for performance. And the visualization piece is very key as well. This goes back to convincing developers this is the right thing to do, convincing the business it's the right thing to do. So you can do all this testing. Okay, I've done some performance testing. I've captured some metrics. Now, okay, where do I find them? So what we're finding with this company in the UK is that we're investing a lot in visualizing via dashboarding. So they get a lot of dev teams get a lot of information anyway. Part of the sort of build deploy overnight, so why not add non-functional testing to it and put it in a dashboard? That way everybody sees it. You can, where's the value of this? You can say it's up there. Look, last night's build was performed this way. The previous build performed like this. Last night's build is 50% worse. Why is that? Someone's made a mistake. Some problem. If we weren't doing this testing, we wouldn't know that. And this code could get rolled into maybe production and cause problems from a performance perspective. So making sure, sorry about the creaking, making sure that everyone is aware of where they go to understand the value, the reasons for doing this is very important. Otherwise it won't happen. It's a lot of companies, it's trying to impose a culture of change is very difficult. It's fraught. And it doesn't go as smoothly as you would like. Sometimes it doesn't happen because people don't see the value in what you're trying to do. So this is very, very important. It doesn't just apply to performance testing and dev. Any sort of new process, any new anything you try and introduce, it has to have demonstrable value. And the best way to do that is to have a nice dashboard. It's just something real, tangible. People can look at. I think that's just really, really important. How are we doing for time? Oh, clock it.
10 more minutes before question section.
Oh, okay, that's cool. Okay, in terms of how you automate the visual, or how you actually provide the visualization, who uses Kibana, Grafana, those sort of open source tools? Yeah, you can do some clever stuff with those. Look really pretty, really effective. At the customer I'm working with, we're using SSRS, SQL Server Reporting Services. It's been around for ages. It's pretty clunky, but it does some nice tables. Well, it's whatever makes sense. I mean, if you're unlucky enough to have SSRS as your imposed internal reporting solution, then you can still make some reasonable dashboards with it. But Kibana and Grafana are much better. Grafana, of course, has a Graphite database behind it. It's set up to store time series data specifically, which is like really helpful. No, I don't mean that in a facetious way. It is really helpful that it does do that. It's just whatever is the most appropriate technology to build these visualizations, and it's not difficult to do this sort of stuff. And once you have the data, and once you have that data, you can do anything with it. You can present it in whatever visualizations you need. But it's in fact where I'm working at the moment, we're using all three of these different teams, but we're trying to try to probably standardize on Grafana if we can, but this is another challenge in businesses where, particularly businesses who are, where agile is is their culture in IT. They encourage everybody to do loads of different things. Lots of teams doing their own things around visualizations, testing. It makes it quite hard to and you don't really want to try and impose standards if you can avoid it, because that just gets people. No, I'm not going to do that. So that's all part of this. It's a psychological as well as a technical battle at times. Anyway. But there are some obstacles to adoption, and obviously we've discussed at length, demonstrating the value, justifying that the implementation effort is worthwhile, can be quite difficult. Because remember, we want to get our quality of delivery, our speed of delivery from average to excellent, and that's the only way you can support sort of the sort of rapid release, build, and deployment model. If you've got a lot of problems in the quality of the code you're producing, you're not going to achieve that easily, and particularly if there are performance defects lurking in there that sadly get promoted into production. And you do see it quite a lot. So this performance testing in dev is one way of at least trying to mitigate that to some degree, prove the confidence of what you're delivering is good, well written, and it will perform. It's not going to contribute to scalability issues. You might still have issues later on, but you're shaking out things that are fundamentally broken at an early stage, because we don't want to find that 3 weeks before something goes live, see all the message. The later you find a problem when you're developing software, the more expensive, the more time consuming, the harder it is to fix. That message has been around for years and that hasn't changed. So, and the technical piece, just automating the harvesting and visualization of the data. I actually think that you see a lot of companies who embark on a process of particularly when they move to an agile model, bringing in Jenkins and all the various tools to enable to enable the management of that process, and it's usually a hybrid approach. It'll be borrowing bits in here, a little bit of custom work to link data, to import and export data, and there's a bit of overhead to get this piece done. Hopefully you can leverage something that's already in place for the performance testing and dev piece, but you might have to create it from scratch. But it's important. But it's not necessarily as straightforward as you might think. There's not really any, that I'm aware of, anything off the shelf you can buy. Here it is. It's just install and works. You can get the data piece, you can get the automation piece, then you have to join them together. That always seems to be the case. And it can be an obstacle to bringing this sort of change, if you like. Oops, going the wrong way there. So as I said, automate, makes it easy to adopt. Why not make non-functional testing as part of your own? Who does this sort of thing already? I'm sure there's probably some of you do. No, okay. Well, if you think about it, build, deploy, does it work? Yes. Functional testing, does it work? Yes. And whether it's success, whether it fails or not, it's non-functional testing, why not do it? You can then, it just gets into the loop, results capture, results analysis. You might even set up some alerting. There's been a big change, tell the right people, flash the red lights, whatever it might be. But you want a dashboard and possibly report. So when it becomes part of that automated process, developers are happy. They don't have to do anything extra because it all happens just as part of the overnight. That's where we want to get to ideally. As I say, because if you minimize the apparent impact of the change, then people are going to do it, and they can also see the value here. They're going to like it, they're going to support it. And what we've done with this company in the UK is we work with a couple of teams, and they're basically creating a pilot, a showcase, and then get everyone around to see all the good stuff we've done. They'll get excited and want to do the same thing. That seems to be the best way in a lot of businesses to promote change in a nice collaborative way, rather than come and say, you are going to do this now, and that just doesn't work in a lot of companies. So I think this is the point we're at with the pilot I'm working on. We've got a reasonable amount of non-functional testing capability built into what the developers are doing. We're leveraging existing functional automation. You can use Selenium, you can use anything that works you can potentially use for this. And it's starting to bear fruit, as we say. Just on tooling choices, any and all of this can apply to performance testing there. We talked about the visualization piece. All these things feed data potentially into here, and then we can dashboard it and visualize it. But you might be using any or all of these for your automation. Obviously, HP Load Runner, or it's just those have been bought by UK companies, so I don't know what they're going to call themselves now. Probably one of the longest running classical performance testing tool sets. There's many more to choose from, so I guess you've all heard of these, or most of these. In the open source world, JMeter has been around for ages. I absolutely hate it, but a lot of people use it, and it's free, and there's about 1 million plugins, so you can make it just about do anything if you're brave enough. It's actually quite a common choice, I think, for automation, or performance automation, if you like, in dev. It's, again, because it's free, it's a lot of people know about it, it's relatively easy to certainly for web testing. But nothing to stop you using something like Selenium, more functional, Neoload. I do work with these guys, whatever works, but the important thing is you don't necessarily have to make a new tooling investment to do performance testing in dev, and I think that's important. So the business is happy about not having to pay more tooling licenses. Monitoring, obviously whatever your platform is, if you're Windows shop, most of your data is going to come from Performance Monitor or the Azure Diagnostic Agent, horrible thing which deposits data and then you have to extract it various ways. Probably we pull it into Kibana, get it from there, correlate it back with your test results. But you could be a Linux or Unix shop. And you, as you say, you can also bring the APM tooling into play as well. In fact, the company I'm working with is looking at New Relic currently. You've probably heard of New Relic, service-based APM solution, providing you allow it through your firewall. You could use it anywhere, including in dev. That's a little difficult, actually. It takes a lot of convincing SecOps to say, open my firewall so I can use a tool in dev. No, maybe not. But some people do it. So you have a lot of choice. You may have any or all of these tools available in the business, so why not leverage them? I mean, many companies, I think, are guilty of having, particularly on size, of having the licenses for the same tools spread far and wide. So, you buy a license for, I don't know, case of Microsoft Visual Studio Ultimate is another performance testing. If you're using TFS, then and you buy the Ultimate version of this, you get the performance testing built in as well, which is quite handy. So, I think we're about ready to look at a few takeaways. How are we doing?
Well, 4 minutes before questions.
4 minutes, okay. So, major takeaway, performance test in dev. Tried to position the case there, I think. Hopefully I've managed to articulate the sort of value, the reasons for doing it, why it's not just a complete waste of time, but it does actually, and it does make a difference, particularly I think it raises the awareness of performance. I mean, this is a DevOps thing as well. Awareness, not just dev, test, ops, all working in their little silos. If you start people thinking about performance by design, so designing performance into an application, early on, get the Scrum teams on board. It starts to spread the love. Is that the word? You know what I mean? But it raises the awareness right across IT. And that's a very, very much a DevOps thing. And obviously, improves speed and quality of delivery. We've hammered home that message a few times. Finding and fixing performance defects early on. Obviously, better to do it early. Automation's key to getting this adopted, and the visualization piece as well. So, any thoughts? Does that make sense? Okay. It's so I finished a trifle earlier than I anticipated, but if there are any questions, please.
Time for questions?
Good.
So the question is, on which environment do you run performance tests? Do you have any shared resources that may be affected by some performance tests running by another developer? How do you ensure that there is no impact from another running?
I think when you're testing in dev, I think there's much less chance. It's not impossible that could occur, but I think it's much more self-contained. So you're less likely to suffer that sort of problem. Obviously in more, I suppose, end-to-end type performance testing, where you've got more and more of the infrastructure, more and more of the environment that you need, you have to be careful when you run that test, so scheduling them at the right times. What we found implementing this in the UK is that it can be very much left to I'll call them platform teams, if you like, to do that testing, manage it themselves. I mean, the test environments invariably are in Azure or in Navisite, or most of the environments are virtualized or cloud-based, so it gives them quite a bit of control. The environments are just there for the purposes of testing, then they're gone. Where there's perhaps two teams that are working together, and one is a consumer, one is providing a service, they collaborate to ensure that the environment that they need to share for testing, that sort of conflict doesn't go on. So it does require a little bit of management, but because you're testing very specific things, then we try and restrict it to, because if you think about it, I have a consumer which consumes a service, which consumes another, which consumes another, and there I'm rapidly in end-to-end testing. So what we do is we made the decision that the performance testing that we do is very much consumer, service, and anything this might need is just stubbed out. Interested in, if you like, this very, very localized testing. So that makes it easier to avoid possible conflicts. You still have to be careful, but the reality of what we've found so far is that we haven't run into any problems of that nature. Does that answer your question?
Well, yes, but generally we were running performance tests on different environments and different hardware, and that's caused us.
Oh yeah, there's a potential for problem, but it's something that has to be managed. But just as I say, because you're being very specific in what you're testing, it should minimise the chances of unintentional conflict, if you like. It's a little challenge there, but and again, it depends very much whether I suppose your hosting infrastructure is a traditional environment, either physical or virtual servers, or you're using something like platform as a service extensively, or just cloud extensively. I think cloud, if you are using cloud, it gives you a bit more control, because you invariably create things, as I say, that are just transitional. They're just there, tested, and they're gone. Sort of build up, tear down. So to plan that, then that sort of taking into account possible conflict as part of creating that sort of test environment. But nothing's perfect, certainly, but it seems to be adding value, and the teams that we've implemented it with seem happy with the testing process. They don't feel that the results they're getting, if you like, are being coloured or interfered with by background tasks. Because often it is just literally the consumer and the service, and absolutely nothing else going on. So it's almost like a clean room test. Certainly we found a lot of situations. So you get a very, I suppose, specific view of the performance of what you're testing. But it's not intended. It is literally to shake out things that are fundamentally broken. Anything to do with capacity, or okay, if you have a business SLA that says this component must process 1,000 orders within 30 seconds, and your environment can support that, you can test that. With the caveat that that's all you're testing. So normally that would wait for more, I suppose, more end-to-end type testing, or when there's more of the application around. Any other questions at all? Okay. Well, thank you very much for your time. I hope that was interesting. Oh, thank you.
Welcome to Moscow. We have a small appreciation.
Oh, that's very
present
kind of you.
that was, like,
Thank
very
you.
useful, thought through presentation.